Alright, we've just completed previously an orthogonal projection of a simple object, this block. And orthogonal projections show typically a front view, a top view, there's a top view, and a right hand side view when we use the standard which Australia uses called third angle projection. And they're always in that order, and they always are aligned to each other like this. That's important to remember that, and I've shown you how you can project dimensions across an efficient way of being able to transfer size from one view to the other. Okay, what about if we want to look at a pictorial view? And in this case we're going to change, and we want to view this object as an isometric. Now isometric drawings, you will recall, isometric drawings require a viewing plane, and they feature two equal angles, isos being the Greek word for equal. So I'm going to divide my page up into, I've measured up a sort of a rough distance over here, and I'm going to divide my page in two, or approximately in two, put a vertical line here, and then use, from that intersection of that horizontal and vertical line that I've created, I'm going to use two 30-degree lines. Now you notice I'm getting the 30-degree line by making sure that my T-square is well and truly pushed up in the side of my drawing board, so there's no rock in it. It's nice and right angles, perpendicular to my board. Then I'm pressing my set square, 30-degree set square, running it along the edge of the T-square until it just intersects the horizontal and vertical lines that I've drawn, and I'm drawing a line outwards. Light line because it's a construction line. I'll draw these a little bit more heavily, these construction lines, for you guys, because it's a bit harder to see on the movie projection, but so that you wouldn't normally draw them this heavily, but just so that you can see them, I'll draw them like that. And that forms really the front edge of this object which we're going to draw in isometric projection. So it's going to look a little bit like that, sitting on the page. That's the kind of representation we're going to have. Something like that. Alright, so as we mentioned before, the dimensions along the planes, right angle planes, will be true dimensions. So the object is 45 millimeters in width, so I'm going to measure up 45 millimeters with my nice sharp pencil. Please make sure it's sharp. And then measure the length of the object, which I'm measuring at 100 millimeters. And I'm going to create a box shape. So really, when you draw isometric drawings, it's kind of like a good idea to create an outline as if the whole thing sat inside a box. So how tall would it be? I think it's 45 millimeters again. So I measure 45 millimeters from the front edge all the way to the top here. Because once again, I'm creating a box shape. I'm not trying to create all the details. I'm just working out where the box fits. So there's our lines. So now you can see there's a box shape appearing over here. There's also a back edge, so I'm going to indicate that back edge over here. And then later on I'm going to cut some chunks out of this box to create the exact shape. So can you get the idea that there's a box going on here? There's the box shape. Here's the vertices. There's my dogs going feral. Probably spotted a blue-tongued lizard or a cat or something like that. So there's the vertices there, and we've got the box. Now, next thing I need to know is that I've got this step section cut away, and it happens to be 52 and a bit millimeters in from the front edge. So I'm measuring out 52 and a little bit there. I'll make a small mark, and I'm going to draw a line upwards, vertically upwards, because it's a vertical edge, as you can see. Now, the thickness of this cutout step section is about 15 millimeters. So again, from my front edge, I'm measuring out 15 millimeters. I could use the front edge, or I could use this edge over here, 15 millimeters. You'll see it doesn't really matter, because when I draw my 30-degree line, which is parallel to that edge, it's the same all the way across. Now I'm going to trace this line out because that edge travels around the top and goes around the other side. So it's still in the same plane. So it'll go back and return along that edge. And once again, I'm going to have another edge sitting here in the same plane. And I'm going to have another edge sitting about there in the same plane. Points of intersection. Now, at this back edge here, which is this edge on the drawing, that back edge, there's a vertical rise, so it goes straight up. So I'm going to take a line from that edge straight up to the top like this. And if I've done my job correctly, these two lines, these two intersection points, there and there, should be aligned. And look at there they are. So now if I were to firm in this outline, which I shall do for you, you're going to see I've got the shape of my object. And it's starting to look a little bit like a 3D shape, which is what we really want. So there's another line here. And another line there. And when you're doing technical drawings, probably a good idea in this type of manual technical drawing is to make sure when you draw lines that you keep your pencil at the same angle. Don't wobble your pencil backwards and forwards, because as you do so, you'll find that your line will start to move away from the edge of your ruler. So try and set your wrist and then draw with the same angle of the pencil all the way through. Alright, once again here from the top edge, lining up like this, following my lines carefully, keeping my pencil nice and still. I'm getting my shape. Now if your tech drawing board's a little bit rough like mine is, you might get some little bumps and wobbles at the bottom. Don't stress over those, because they too can be solved if you just want to put two sheets of paper underneath. So one adds as a bit of a buffer. So instead of just putting one sheet of paper on your page, put a second sheet of paper underneath, and you can stick them both down with one bit of sticky tape on either corner, and they'll work really well for you and provide a better drawing surface. I've only used one here, but I can still see some bumps in my drawing. Okay, now that's looking pretty good. Can you spot a mistake in my drawing? I bet you can. Okay, what's happening over here? Yes, you've guessed it. You got me. We've actually drawn a line which we shouldn't have drawn. There's a line down here which shouldn't be there. And if I have my trusty eraser hanging around, which I do, let's get rid of it. And you know one of the other mistakes I've made? I've drawn this line in firmly without checking it. So it's going to be hard to make sure that line disappears. So please double check your lines before you get too firm with it. Okay, so there's our shape. Starting to look a little bit more like what we want. Yes, it is. One thing we've missed out too. See this chamfered edge over here? We haven't allowed for that, have we? Okay, so what are we going to do here? Alright, well let's work it out. It's going to be roughly measuring here 5mm or 6mm in from one edge and approximately 6mm in from the other. So if I measure 6mm in, make a small dot from the top edge, 6mm down, make a small dot from the bottom edge, and then join those two dots by lining them up nice and carefully. I now have my chamfered edge. And on top of that, I'm going to have this top edge will have to be drawn all the way across. Now, of course, what that means is I've drawn these thick lines here, now they have to be rubbed out. So it's a good idea to show you exactly why you need to draw mostly things in lightly before you go heavy with your final outlines. And as far as line work goes, all hidden detail lines, all construction lines, they should all be of a light order. The actual outline of the object should be a heavy line, and the rest should be just faint lines. And you can leave them on your drawing, you don't need to rub them out. But you start to see now we're starting to get an appearance of what that object looks like. And it's pretty well accurate to what the object itself is, right? So that's looking good. Now comes the hard part. We've got to draw this circle. And because the circle is not parallel to either one of the two right angle planes, these two 30-degree planes, it's not going to appear to be exactly round. I'm going to assume it's in the middle, although we could measure and say, okay, it's around about 20mm in from one edge, and that would bring it off to one side a little bit. But I want to make it in the middle, so I'm going to make it at 45mm. It's going to be 22.5mm. So I'm going to measure there, draw this center line. Now when you're drawing isometric drawings, you don't show hidden detail, neither do you necessarily show anything to do with hidden views, because it's a pictorial drawing. It's really meant to give a representation of what the object would look like. Okay, and we'll do the center of the circle just here, like that. So there's the center of our circle. Now it's only a tiny little circle, so what we want to do now is learn how to draw an isometric circle. And this exercise over here is kind of quite fun, and I suggest what we do is, rather than start it on a page, I'm going to show you how to do it on a new page. So I line this page up, put a couple of bits of sticky tape on here, and show you how to do an isometric circle, which is on a bit of larger scale, because it's a whole lot easier when it's on a larger scale. And then you can transfer that to a small scale if you want later on when you have to do that little hole. Okay, so there's the second sheet of paper. Let's do our isometric base just like we would on anything else. A vertical and a horizontal, and we're going to do an isometric circle which is going to be 50 millimeters, a 50 millimeter diameter circle. So there's my 30 degrees on one side, 30 degrees on the other. Now if it's 50 millimeters diameter, it'll sit inside a 50 millimeter square, will it not? So I should be able to measure 50 millimeters and make a mark like that. Now here you're going to need your compass. Here's my compass. You're going to need your compass, and you can use your compass to good advantage to save yourself a lot of measuring time and get some consistency. So use your compass as a set of dividers, which are essentially what ancient cartographers used to use to measure distances, and I guess before the days of computers. So I'm stepping it out, I'm using this knurl nut, and then there's my other dimension. Now of course, if my lines are all perfectly symmetrical, these lines, two lines, should add up. And yes, they do. They're equal along the line here. Alright, I'm going to now create the rest of my circle, like so, and join up. And this would be the flat box, if you like, the isometric box in which our circle will sit. Alright, all well and good. Now, how do we get the exact shape of this box to match it and what we want? What are we going to do? Alright, first thing is we need to measure halfway between each of these sides. So if they're 50 millimeters, it's going to be 25 millimeters. Now I can do that. It's a technique which you can use using a compass. You might learn this in maths. I'll show it to you now. Put your leg of your compass on one side of the circle. Make an arc which is slightly larger than halfway. Do the same on the other side. Make again that arc slightly larger than halfway. I should complete that arc a little bit like this. And when you draw the two around, that should give you exactly the center of a line that you're talking about. Another way is just to measure it or step off the distance. Okay. So, and by the way, just to prove it, if I drew those two lines together from the intersection of the two tangency points here, I would go exactly through the center, and there it is. Okay, that's good. We do need that construction line. I'm going to use my compass again because I just love using compasses. They're a lot of fun. And again, adjust the compass, use it one-handed. That's good. And I'm going to step off my halfway point. So I know halfway around each side of this circle. Now I could step it all out, or I can just use my 30-60 set square like that. That's my 45. And transfer that line across and say, okay, there's halfway there. Transfer the line across halfway here, like this. So now I have halfway points, there they are, for each of the four sides on which my isometric circle is going to sit. Okay, the next stage in this drawing is to create 2 points of intersection between the obtuse angle of the square and the opposite edges. So there's one. And I'm doing these very thickly and firmly. You would only do them as construction lines, and there's the other. Do the same on the other side, from the obtuse angle to the opposite halfway point, the opposite side, and we're creating intersection points, and those intersection points are going to be very useful for us to generate the small arc of the curve. So we're left with a shape like this. Okay, now the next part is very simple, and if we've done our job well, it should be beautifully accurate as well. So I'm going to wind this out. Hopefully I'll get out of your shade so you can see what I'm doing. So step the one point of your compass on the obtuse edge, and then go from that opposite edge around and create an arc like that. Do the same on the opposite on the other side. Create the arc, and you should be just touching those 2 points of that intersection of that line that you've created from the obtuse angle to the opposite edge. on either side. Now the next stage is probably a little bit more of the difficult stage, and that is, if you've done your job well, it should work out beautifully. Set your compass so that, I'll try and get out of the light here, so that your pin is on the point of intersection of those two lines that we just set out earlier and touches the outer edge, and it should just line up with the end of the large arc that you've created. And the same thing should happen on the other side. Now if it doesn't, you might have to move your point just slightly to get them to line up. There they are, like that, and create a small arc. That's your small arc of your isometric circle. Do the same on the other side, and you'll get the small arc of that isometric circle on the other side, and there you are. And that's your isometric circle. And that's how you design them. Well, that's one technique for designing the isometric circles. Now this is rather difficult to do when we've got a very small circle, because we've got tiny little distances and tiny kind of situations. But if you know how to construct one, you can actually construct one by hand quite successfully. So we're going to have to do a small circle over here, and the diameter of this circle is 12 millimeters. So let me show you how I would do it. You can get yourself some templates which have isometric circles built into them, and I don't have any, and they make life very easy for you because there'll be a 12 millimeter one for sure. Or you can just build up a box the way I did, I showed you just before, and use the technique that you know in the appropriate way. So there's 6 millimeters, and there's 6 millimeters. So I'm going to create a box. It's going to be a small box. 2 light construction lines. And then I'm going to measure across the other axis of symmetry which I've created with my center line. There. 6 millimeters out from the center. Use my 30-60 set square to very carefully create another remaining 2 edges of the box. So there is the box now. Here, one edge, second edge, third edge, fourth edge. My circle has to sit within that box. That's a 12 millimeter box. Now we know from past experience, from learning how to do this, that if I put the compass point here and put my edge up to the middle of the opposite side, opposite edge, I should produce the large arc of my isometric circle. Doing the same on the other side, and again it's much more difficult with a smaller circle like this. I should be able to produce the second large arc. There it is. Now the small arcs are very difficult to produce, so I'm going to do them freehand. They go in and around like that. Do them lightly and then go over them firmly, creating the egg shape. And there's our isometric circle. Now we wouldn't show hidden detail here because we don't show hidden detail on isometric views, but what we have now is quite an accurate representation of our block. There it is. Try and line it up a little bit in 30 degrees, and there's our block. Okay, and there's how to draw a simple isometric drawing. Thank you.